Good iPhone. Excellent. All right, now what we're going to do is, let's get back to the question. What's the time constant? 10. I'm renowned for wanting stuff to cancel. Mega is 10 to the 6, micro is 10 to the negative 6. How do you get the time constant? R times C. The 10 to the 6 cancels with the 10 to the negative 6, so you're left with 5 times 2, which is 10. 10 seconds. So in the event of a charging situation, it's going to go up like this. In the event of a discharging situation, it's going to go down like that. The charging equation has V equals V naught 1 minus e to the negative t over tau. The discharging is V equals V naught e, or V max, e to the negative t over tau. These things are all going to be hooked up to 100 volt batteries. The time, horizontal, V is vertical. And what I'm going to do is, we're going to power through these number-wise. I've got 9 minutes and I'm going to use them. Each block of 2 squares is 10 seconds. But it's also an interval of tau, 2 tau, 3 tau, 4 tau, 1, 2, 3, 4, tau, 2 tau, or 20, 3 tau, or 40, 4 tau, or 40, whatever that multiple of tau is. In our case, it's 10 because I just wanted it to be easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 100. And what I'm going to do is I'm just going to plot this out by hand. And my t, I'm just going to use the values of tau, 2 tau, 3 tau, and 4 tau. Discharging time values of tau, 2 tau, 3 tau, and 4 tau. One minus e to the negative tau over tau. 1 minus e to the negative 2 tau over tau. 1 minus e to the negative 3t over tau. Oh, I wrote them in the wrong place. That goes there, that goes there, that goes there. 1 minus e to the negative 4 tau over tau. So in all of these cases, the taus cancel. And I'm left with 1 minus e to the negative 1, 1 minus e to the negative 2, 1 minus e to the negative 3, 1 minus e to the negative 4. For the discharging, it's e to the negative tau over tau, e to the negative 2 tau over tau. Now really what I'm going to do is I'm going to find these values and multiply them by 100. That's why I made it 100, so that I can easily crank these out. E to the negative 3 tau over tau, e to the negative 4 tau over tau. This gives me e to the negative 1, e to the negative 2, e to the negative 3, e to the negative 4. So e to the negative 1 is 0.37. They're extra numbers, but I don't care about them. In terms of hand drawing this stuff, I don't need it. E negative 2, 0.14. E negative 3, 0.05. E negative 4, 0.02. Now what I did is I did those first so that I can do these next. 1 minus this, 0.63. 1 minus this, 0.86. 1 minus this, 0.95. 1 minus this, 0.98. So all I did was I found what e to the negative 1, e to the negative 2, e to the negative 3. 4 minutes will be done in 2. So multiply by 100, I get 63, 86, 95, 98. At 10 seconds, the voltage is 63, 20 seconds is 86, 30 seconds is 95, 40 seconds is 98. This goes 37, 14, 5, and 2. So plot these out. 63 is about like that. 86 is about like this. 95 is about like that. 98 is about like that. 37 is about like this. 14 is about there. 5 is about there. And 2 is about there. So what someone asked yesterday is like, what is the meaning of tau? And tau just shows you that there are specific times where you get very nice numbers in the exponential. E to the negative 1, e to the negative 2. That's what tau is. And when you draw it out, that one's horrible. You get something like that. And so these are exponential growth and decay lines. And this is something that you'll have to do in lab in a couple of days. Oh, did it in 2 minutes. We're done. This will be posted up shortly. Homework due at 6.